How are you doing today?
Doing good, Leo. What about you?
I'm doing very good. Thanks for asking. But I'm studying for my finals on Monday, and I'm having a really hard time remembering and understanding the process of DNA replication. I was wondering if you can help me with this?
Absolutely. Is there any step in DNA replication that you're stuck with?
Well, I know that the double helix has to be split in the middle to make another strand of DNA, and that there are base pairs involved. But I can't remember much of the details after that.
No worries. We'll work with that information and review a few terms as we go through the step-by-step process of DNA replication. Now, we know that DNA replication starts with the splitting of the double helix. Do you remember what's responsible for the splitting or cutting of the double helix?
I know it's a type of enzyme, but I can't remember the term for it.
You're absolutely right. So the name of the enzyme that's responsible for unzipping or cutting the double helix is our helicase. So it's usually situated over here. And it works its way up until it unzips the whole double-stranded DNA. Now we're going to have two different strands, which is the 3' to 5' strand and the 5' to 3' strand. Now the 3' to 5' strand is what we call our leading strand, and our 5' to 3' strand is what we call our lagging strand. Now we also have a fork over here, and that fork is what we call our replication fork. Now, do you remember what happens after that?
Something starts the replication process on both ends. I'm thinking it's another enzyme because that's what we used to start unzipping.
You're absolutely right. Every step in DNA replication involves an enzyme. So the enzyme primase will then form a primer, which always works its way from 3' to 5'. Do you remember what happens after that?
Not really.
That's okay. So we're going to focus on the 3' to 5' strand first, or our leading strand. So once the primer is attached to the 3' part, it works its way using the DNA polymerase, which is another enzyme, and it works its way upwards to form the complementary base pairs. Now, once this double helix is completely cut or completely unzipped, we're going to have this DNA polymerase go through to the end. And once we create that double-stranded helix that we want, we're going to have ligase that helps in adhering those strands together and forming our DNA, double-stranded DNA. Could you say this continuous process also happens from the 3' to 5'?
I don't think so, because there's the other strand that's called the lagging strand.
Correct. Remember how the primer always binds from the 3' to the 5' direction, and do you also remember our replication fork?
Yes.
Using that information, how will you know why the 5' to the 3' DNA strand is the lagging strand?
I'm thinking since the primer attaches closer to the replication fork and works its way down to the end, the process is cut short.
You're absolutely right. You did a great job in piecing the information together and come up with the answer. Because of the fork, the primer has to attach itself again as the unwinding continues and is finished. That is why we have the breaks in the strands, which will now be called as our Okazaki fragments. So it usually goes this direction and will form tiny, tiny fragments.
Oh, I see why the labels on the strands are important. After that step for the lagging strand, its ligase glues them together to form the double-stranded DNA. Am I correct?
You got it! Now that you understand the process of DNA replication, I'll give you a few minutes to recall what we've learned today and walk me through the whole process afterwards. Is that okay with you?
Sure thing. Thank you for your help.
No worries.
The student's learning goal was to recall and understand some of the processes of DNA replication, as well as the enzymes and terminologies involved. Assessing the student's skill level by asking what step will follow afterwards helped him recognize the information he already knew and gradually piece the concept together, thereby making him a novice in the subject matter. Recalling definitions and reiterating basic facts were done to complete the concept of DNA replication. Throughout the session, the student was asked to hypothesize what the outcome would be in certain types of DNA replication. After the discussion, the student was asked to unpack the concepts to the tutor. Growth mindset feedback was incorporated when the student was praised for using critical thinking skills to synthesize an answer out of the information given during the session.